This is part 3 of chapter on reflection. We had seen 3 types of reflection. One is reflection in the x-axis, second one reflection on the y-axis, and the third one is reflection in the origin. Other than these 3 reflections, you're going to see reflection of certain points on some other lines. Some other lines which I am talking about. If you talk about x-axis as the equation y is equal to 0, because on the x-axis all values that you will plot on the x-axis will have y value 0. That's why its equation is y is equal to 0. Similarly, the equation of the y-axis is x is equal to 0, because if you plot any point on the y-axis, and if you notice all those points will have x coordinate to be 0. That's why the equation of the y-axis is x is equal to 0. Now you're going to see reflection of these points on different lines. I said those different lines are lines either parallel to the x-axis or they are parallel to the y-axis. If they are parallel to the x-axis, then their equations will be y is equal to 1, or y is equal to 2, y is equal to 3, or y is equal to minus 1, y is equal to minus 2, y is equal to minus 3, and so on. Because equation of the x-axis is y is equal to 0. Anything which is parallel to it will have equations y is equal to some value, okay, depending on which value of y that line passes through. Similarly, any line which is parallel to the y-axis will have equation x is equal to some value, either a positive value or a negative value. Okay. So these lines are either parallel to the x-axis or parallel to the y-axis. The first one, A's coordinates are 3, 5, and this is going to be reflected in the mirror x is equal to 2. X is equal to 2 is not the x-axis. This is a line which is parallel to the y-axis and it passes through x value 2. Okay. So this is not the x-axis or y-axis or the origin. Okay. It's a line which is either parallel to the x-axis or the y-axis. In this case, this is a line parallel to the y-axis, okay, and passing through the value x is equal to 2. So mirror is x is equal to 2. Okay. So if you are going to reflect on this line, because its value is x is equal to 2, x values will change, y values will not change. This is not the normal procedure. Okay. So we are going to reflect in the line x is equal to 2. Therefore, x coordinate is going to change, y coordinate is not going to change, which means phi will remain the same. So a becomes a dash and phi remains the same. Y value is not going to change. It's only the x value which is going to change. I'll show you a simple method of how to do this. If you can find some other methods, you can use them. Okay. Now, the line on which it is reflected is x is equal to 2. The value here is 2. What I'm going to do this 2 is double it. The double value of 2 is 4. I'm writing the 4 below. This 4 is the double of 2. Now this 4 is not only the double of 2, it is also the sum of both the x values. That is, if you add this x value and this x value, you should get this 4. So 3 with something should give you the 4. So 3 plus this is 1. 3 and 1, if you add, you will get the 4. Okay. So again, I'll repeat. A's coordinates are 3, 5. It is reflected in the line x is equal to 2. All that I did was double of 2 is 4. I have written that here. It's the double of 2. It's also the sum of both the x values. 3 added with some number should give you the 4. Okay. So 3 plus 1 gives you the 4. So coordinates of a dash is 1, 5. Similarly, a second example. B's coordinates are 4, 0. It is going to be reflected in the mirror y is equal to 4. So B changes to B dash. Because it is reflected in y is equal to 4, y coordinates will change, not the x coordinate. So x coordinate remains the same, that's 4. Okay. And the y coordinate is going to change. Now, what we do here is, the value here is 4. Double this one, that will give you 8. This 8 is the double value of this, and also 8 is the sum of both the y values. 0 plus something should give you the 8. So 0 plus 8 will give you the 8. Okay. So B dash's coordinates are 4, 8. Third example. C's coordinates are minus 3, minus 5. It is reflected in the line x is equal to 4. Okay. Because it is reflected in x is equal to 4, x coordinate sign is going to change, not y coordinate sign. Okay. So y coordinate remains the same, that's minus 5. It's only the x coordinate which is going to change. Now, the value here is 4, double this, that will give you the 8. Okay. This is the sum of both the x values. That's minus 3 added with something should give you 8. Okay. If you are not sure about that, you can do this. Minus 3 with something, that's something you can assume as x. Okay. So I'm doing it on the side. So minus 3 plus something should give you a sum which is 8. Okay. So take the minus 3, that's it. X is equal to 8 plus 3, that will give you 11. So this value is 11. 11 minus 3 will give you the 8. Okay. Next. The next example. D's coordinates are 0, minus 7 is reflected in the line y is equal to minus 2. So D becomes D dash. Because it is reflected in y is equal to minus 2, y's coordinate is going to change, not the x coordinate. So x coordinate remains the same, that's 0. Now what we do this to this is double it. Minus 2 if you double, you will get minus 4. Now this is the sum of both the y values. Minus 7 with something should give you minus 4. If you are not sure, write it on the side and add up and see. That's minus 7 plus something should give you the minus 4. Okay. Minus 7 plus the something I have assumed as y is equal to minus 4. This and this added together should give you this. Okay. So take the minus 7, that's it. So you get y is equal to minus 4 plus 7, that will give you 3. Okay. Minus 4 plus 7, that gives you the 3. So which means this is 3. Okay. And the last example. E's coordinates are 7, 4. And it is reflected in some mirror, you don't know which is the mirror. And E becomes E dash. And the coordinates are 7 and 12. Compare both of them. See what has changed, what has not changed. This was 7, it remains the same, 7, which means it is not reflected in the line x is equal to something, because x is not changing. It is reflected in y is equal to something, because look at the y values. 4 has become 12, which means the mirror is y is equal to something. Okay. As I told you, the value which you write below is the double of whatever is here, but you don't know what is here. It should be the double of whatever is here. And this number which you get is also the sum of both the y values. That is 4 and 12 added together should give you that number which should be here. That is 4 plus 12 gives you a 16. So 16 is the sum of both these, and the 16 is also the double value of what number should have been here. Okay. So 16 is the double of 8, which means this line on which it is reflected is y is equal to 8. So that's the mirror. The mirror is y is equal to 8. Okay. This is from exercise 12, question number 12. A is the point 2, 1. Find, number 1, the point A1, which is the reflection of A in the line x is equal to 3. That's the first question. So let's do the first question. A's coordinates you know. Okay. A's coordinates are 2, 1. Where is it reflected? It's reflected in the line x is equal to 3. So I've written mirror is x is equal to 3. And A becomes A1. That's what it says. Point A1 is what you get, A1. Okay. Now, it is reflected in the line x is equal to 3, which means x coordinates are going to change, y coordinate is not going to change. So the 1 remains the same. Okay. Now, the value that you see here is 3. Double this one, you will get the 6. The 6 is also the sum of both the x values. 2 added with something should give you the 6. So 2 plus 4 will give you the 6. Therefore, coordinates of A1 is 4, 1. Second question is, find the coordinates of A2, which is the reflection of A1 in the line x is equal to 6. Okay. So, the second one. You're going to find the coordinates of A2, which is the reflection of A1. So, which means you're going to start with A1 and reflect it in the line x is equal to 6. So, you start with A1. A1's coordinates are 4, 1. It is reflected in the line mirror x is equal to 6. To get point A2, again, it is reflected in the line x is equal to something. Therefore, x values are going to change, not the y value. So, y value I have written same, 1. Okay. The value that you see here is 6. Double this one, you will get 12. The 12 is also the sum of both the x values added together. So 4 with something should give you the 12. So 4 plus 8 gives you the 12. So the coordinates of A2 is 8, 1. There's a third question. It says, given that A2 is the reflection of A in the line x is equal to k. A2 is the reflection. A2 is the image of A. So you are starting with A and you're going to get A2. That is when you are reflecting in the line x is equal to k. This number is not known. Okay. So find the value of k. K is what you have to find. Okay. So for that, you start with A. A's coordinates are 2, 1. Okay. And you get point A2. A2 you already know. A2 is 8, 1. And it is reflected in the mirror x is equal to k. Mirror is x is equal to k. Okay. Now, see what has happened. A is 2, 1. A2 is 8, 1. See what has changed. Y value has not changed, which means this is correct. It is x is equal to something. Now, x previously was 2. Now it is 8. The double value of this is what you will write below. But you don't know this, therefore don't write anything now. This value which you get is also the sum of both the x values. That is 2 plus 8 should give you this number. That's 2 plus 8 is 10. So that's 10. And this 10 is also the double value of what was supposed to be there. Okay. So double of what is 10? That's double of 5. Therefore x is equal to k is actually x is equal to double value of 5 is 10. So this is 5. Therefore, k is equal to 5. Next, question number 19. A point L whose coordinates are -3, 4 is reflected in the line y is equal to 3. To a point L dash, find the coordinates of L dash. You are starting with point L. L's coordinates are -3, 4. It is reflected in the line y is equal to 3, which means the mirror is y is equal to 3. Because it is reflected in y is equal to something, y coordinate sign value should change, not x. So the -3 remains same for L dash. Okay. The value here is 3, double of this is 6. Okay. The 6 is also the sum of both the y values. So 4 added with something should give you the 6. So 4 plus 2 gives you the 6. So this is L dash whose coordinates are -3, 2. Next question is question 16. A point P whose coordinates are A, B is reflected in the x-axis to P dash whose coordinates are 2, -3. Write down the values of A and B. P dash is the image, P double dash is the image of P when reflected in the y-axis. Write down the coordinates of P double dash. Find the coordinates of P triple dash when P is reflected in the line parallel to the y-axis such that x is equal to 4. We'll go one at a time. Okay. A point P whose coordinates are A, B is reflected in the x-axis to P dash whose coordinates are known. You started with P and after reflection it became P dash. Okay. P is not known, but you know the image. image P dash is 2 minus 3. Okay. Now, it is reflected in the x-axis, you know for sure. Whether you reflect P on the x-axis and get P dash, or if you do the reverse, if you reflect even P dash on the x-axis, you should get back whatever is P. This is the object, this is the image. You start with an object, you reflect on the x-axis, you get an image. If you start with the image, if you reflect on the same axis, you will get back whatever was the object. So instead of starting from P, you can start from whatever is known and do the same reflection. So the first part is start with P dash. P dash is 2 minus 3 is reflected in the x-axis, so mx. When you reflect on the x-axis, y sign will change. Okay? So which means this sign is going to change. So P actually, original object P is 2 remains same, minus 3 becomes 3. But according to the question, P's coordinates are A, B, that I have written below. P's coordinates are A, B, which means these 2 points are same. It means A's value is 2, B's value is 3. So A is 2, B is equal to 3. The second part of the question is, now you know A and B, which means P's coordinates are 2, 3. P's coordinates are 2, 3 is known. P double dash is the image of P when reflected in the y-axis. Write down the coordinates of P double dash. Okay. P double dash is the image of P. Okay. So we are going to start from P. P is 2, 3. It is reflected in the y-axis. So my. If you reflect any point on the y-axis, x's sign will change. P becomes P double dash. X's sign changes. 2 becomes minus 2 and 3 remains the same. So you found P double dash. Next, find the coordinates of P triple dash when P is reflected in the line parallel to the y-axis such that x is equal to 4. P is reflected and you get P triple dash, and this is done in the line x is equal to 4. So you start with P 2, 3, it is reflected in the line x is equal to 4. P becomes P triple dash. Now, this is not normal reflection, not with the x-axis, y-axis or origin. Because it is reflected in x is equal to 4, x coordinates are going to change, not the y coordinate. So y coordinate remains the same, that's 3. Now the value here is 4, double this one you will get 8. The 8 is also the sum of both the x coordinates. That is 2 is known, this is not known. 2 plus something should give you the 8. So 2 plus 6 gives you the 8. Okay. Then your homework, exercise 12, question number 6, 9 subdivision 3, 14, 18, 20 and 21.